Another day, another story. Several potential subsurface openings have been observed on the surface of the Moon. These lunar pits are interesting in terms of science and for potential future habitation. However, it remains uncertain whether such pits provide access to cave conduits with extensive underground volumes. Here we analyze radar images of the Mare Tranquillitatis pit, MTP, an elliptical skylight with vertical or overhanging walls and a sloping pit floor that seems to extend further underground. Welcome to Tabo Eminent Channel. The images were obtained by the Mini-RF instrument on board the Lunar Reconnaissance Orbiter in 2010. We find that a portion of the radar reflections originating from the MTP can be attributed to a subsurface cave conduit tens of meters long, suggesting that the MTP leads to an accessible cave conduit beneath the Moon's surface. This discovery suggests that the MTP is a promising site for a lunar base, as it offers shelter from the harsh surface environment and could support long-term human exploration of the Moon. This is a preview of subscription content. Welcome to a groundbreaking discovery in lunar exploration. In this video, we unveil the remarkable radar evidence of an accessible cave conduit beneath the Mare Tranquillitatis pit on the Moon. This discovery has the potential to revolutionize our understanding of the Moon's geology and its implications for future lunar exploration. The radar evidence presented in this video showcases the presence of a cave conduit below the Mare Tranquillitatis pit, providing a unique glimpse into the Moon's subsurface. We delve into the technical details of the radar data and its significance in uncovering this hidden lunar feature, shedding light on the geological mysteries of our celestial neighbor. The implications of this discovery are profound, offering new opportunities for future lunar exploration and potential human habitation. The accessibility of a cave conduit could provide valuable resources and shelter for future missions to the Moon, paving the way for sustained lunar exploration and scientific research. Join us in exploring this extraordinary lunar discovery and its implications for the future of space exploration. Engage with the topic by sharing your thoughts and insights in the comments below. Let's ignite a conversation about the potential of this accessible cave conduit and its impact on lunar exploration. Historical context. Apollo missions. The Apollo program by NASA, which ran from 1961 to 1972, was the first successful manned mission to the Moon. Apollo 11, in 1969, marked the first time humans walked on the lunar surface. Robotic missions. Before and after the Apollo missions, several robotic missions by the Soviet Union, United States, China, and other countries have explored the Moon, providing valuable data on its surface and composition. Current and future missions. Artemis program. NASA's Artemis program aims to return humans to the Moon by 2024, with the goal of establishing a sustainable human presence by the end of the decade. Artemis I, an uncrewed mission, launched in 2022 to test the Space Launch System, SLS, and Orion spacecraft. Lunar Gateway, part of the Artemis program. The Lunar Gateway is a planned space station that will orbit the Moon and serve as a staging point for missions to the lunar surface and potentially to Mars. International missions. Countries like China, with its Chang'e program, and Russia, with plans for future Luna missions, are actively pursuing lunar exploration. The European Space Agency, ESA, and private companies are also contributing to lunar missions. Scientific goals. Geology and resources. Studying the Moon's geology helps us understand the history of the solar system. Additionally, identifying resources like water ice at the lunar poles is crucial for future lunar bases and potential missions to Mars. Human health. Lunar missions help us understand the effects of long-term space travel on the human body, which is essential for planning future missions to Mars and beyond. Challenges. Radiation exposure. The Moon lacks a protective atmosphere, exposing astronauts to high levels of radiation. Lunar dust. The abrasive nature of lunar dust poses risks to both equipment and human health. Logistics and sustainability. Ensuring the sustainability of lunar missions, including the continuous supply of necessary resources, remains a significant challenge. International cooperation and policy. Space treaties. The Outer Space Treaty of 1967 provides a legal framework for the peaceful exploration of space, including the Moon. Artemis Accords. These are a series of bilateral agreements between the United States and other nations to establish guidelines for responsible lunar exploration. The first steps: Apollo missions. Apollo 11. In 1969, Neil Armstrong and Buzz Aldrin became the first humans to set foot on the Moon, with Michael Collins orbiting above. Their mission was not only a testament to human ingenuity but also a demonstration of geopolitical prowess during the Cold War. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," echoed around the world, marking a pivotal moment in human history. Renewed ambitions. Artemis program. Artemis I, launched in 2022, this uncrewed mission tested the Space Launch System, SLS, and the Orion spacecraft. Successfully completing a journey around the Moon and returning to Earth, Artemis I laid the groundwork for future crewed missions. Artemis II and III, scheduled for 2024 and 2025, these missions will bring humans back to the lunar surface. Artemis II will fly astronauts around the Moon, while Artemis III aims to land the first woman and the next man on the lunar South Pole. Science and exploration. New frontiers. Water ice discovery. The presence of water ice in the permanently shadowed craters at the lunar poles has profound implications. Water can be split into hydrogen and oxygen, providing not only life support for astronauts but also fuel for rockets, enabling deeper space exploration. Regolith studies. Lunar regolith, or moon dust, is being studied for its potential use in building habitats. Techniques like 3D printing using local materials could revolutionize how we construct structures on the Moon and Mars. International and commercial partnerships. Artemis Accords. These agreements, signed by numerous countries, establish a framework for responsible and transparent lunar exploration. They emphasize peaceful use, the sharing of scientific data, and the protection of heritage sites like the Apollo landing sites. Commercial ventures. Private companies such as SpaceX, Blue Origin, and Astrobotic are playing pivotal roles in lunar exploration. SpaceX's Starship is designed to land on the Moon, while Blue Origin's Blue Moon lander aims to deliver payloads. The future, Mars and beyond. Pathway to Mars. The technologies and experiences gained from lunar missions will be critical for future missions to Mars. Developing life support systems, habitat construction techniques, and efficient transportation on the Moon will provide the necessary groundwork for establishing a human presence on Mars. Long-term vision. Establishing a sustainable lunar base will enable continuous scientific research, resource utilization, and preparation for deeper space missions. In conclusion, the radar evidence of an accessible cave conduit on the Moon below the Mare Tranquillitatis pit represents a major milestone in our understanding of the lunar environment. This discovery not only paves the way for future exploration but also raises the possibility of establishing a permanent human presence on the Moon. As we look to the future, this finding ignites our imagination and fuels our passion for space exploration. Thanks for watching. Request you to subscribe the channel.